Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Programming is the practice of creating instructions that a computer can execute, but beyond the individual commands, it involves organizing those instructions and related data into logical, reusable structures. This organization makes software easier to maintain, expand, and troubleshoot. In the Tech Plus certification, candidates are introduced to essential programming concepts such as variables, functions, arrays, and objects. Understanding these concepts supports code analysis, enables basic automation, and improves communication between IT professionals and development teams. In this episode, we will focus on how programs are constructed using these core building blocks. A variable is essentially a named storage location within a program that can hold data while the program is running. The name of that variable is called an identifier, and identifiers are also used for naming functions, objects, and other program elements. Naming conventions, such as camel case or snake case, vary between programming languages and development teams, but help keep code consistent and readable. Variables allow a program to store, update, and reference data, making the code adaptable to different situations and inputs without rewriting the logic. Declaring a variable means reserving a space for it in the program, while initializing it means assigning it its first value. In some languages, these steps are combined, such as writing int count equals 0 or name equals double quote, Alex double quote. Some programming languages require explicit type declarations, so the compiler or interpreter knows exactly what data will be stored. Others use type inference to decide automatically. In most environments, a variable must be declared before it is used to prevent errors and maintain clarity in the code. Variable scope determines where in the program a variable can be accessed. Global variables are available across the entire program, which can be convenient but also lead to conflicts if multiple parts of the program change them unexpectedly. Local variables exist only within the specific function or block of code where they are created, which helps keep data contained and reduces unintended changes. Understanding scope is important for writing secure, maintainable code and for troubleshooting variable-related issues. Constants are similar to variables in that they store data, but once assigned, their value cannot be changed. They are ideal for storing values that remain fixed throughout the program, such as mathematical constants like pi or configuration values like a tax rate. Most languages have keywords such as const or final to enforce immutability. Using constants improves code safety by preventing accidental changes and improves readability by signaling to others that the value should remain the same. An array is an indexed collection of elements, all stored under a single variable name. Arrays can store numbers, strings, or even more complex objects, with each element accessed by its index, such as scores bracket 0 bracket for the first item. Arrays are essential for handling repetitive data efficiently, especially in loops where each element can be processed in turn. They are used for everything from storing user records to tracking items in inventory. Functions are named blocks of code designed to perform a specific task, which can be reused throughout a program. A function may take inputs, known as parameters, and produce outputs, known as return values. Functions support modular programming by breaking down complex tasks into smaller, manageable parts, improving readability and simplifying testing. For example, you might define a function named greet that accepts a name parameter and outputs a personalized message. Function parameters allow data to be passed into a function so it can operate on specific values, while return values send results back to the part of the program that called the function. Some functions are designed only to perform an action and do not return any data, often referred to as void functions. Understanding how to use parameters and return values effectively enables more dynamic and flexible program design. The difference between a method and a function lies in their context. A function is independent and can be used anywhere in a program, while a method is associated with a specific object or class and operates on its data. For example, Length open parenthesis close parentheses is a method of a string object that returns the number of characters it contains. Knowing when you are dealing with a method versus a standalone function is important in object-oriented programming. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Objects are core components of object-oriented programming, often referred to as OOP, and they combine both data and behavior into a single structure. The data inside an object is stored in attributes, while its behavior is defined by methods. This approach allows developers to model real-world entities in code, such as a user account or a vehicle, by bundling all related information and operations together. Object-oriented programming promotes encapsulation, modularity, and reuse, making it one of the most widely used programming paradigms today. To create an object, you typically start with a class, which is a blueprint that defines what attributes and methods the object will have. Once the class is defined, you use a constructor to create specific instances or objects based on that blueprint. These instances can then be interacted with using dot notation, such as user.name to access an attribute or car.start open parenthesis close parenthesis to call a method. This process keeps data organized and makes it easier to manage complex systems. Attributes represent the stored data within an object, while methods are the actions that operate on that data. For example, a bank account object might have an attribute for balance and methods for deposit and withdraw. Recognizing this distinction is critical because it clarifies how the object functions internally and how it can be used from outside. This understanding also makes debugging and modifying code more straightforward because you know which parts store data and which parts change it. Inheritance is a key feature of object-oriented programming that allows a new class to build upon an existing one. The new class, called the child or subclass, automatically gains the attributes and methods of the original class called the parent or superclass. This approach promotes code reuse, reduces duplication, and keeps programs consistent across related objects. Inheritance is commonly used in frameworks, user interface components, and application architecture to create structured, scalable systems. Encapsulation is the practice of hiding an object's internal data from direct outside access, instead providing controlled ways to interact with it through methods. This protects the integrity of the data, ensuring it is changed only in valid, predictable ways. Access control is typically enforced with mechanisms such as private attributes and public getter or setter methods. Encapsulation makes systems more secure, easier to maintain, and less prone to unintended side effects from outside interference. Comments and documentation are vital tools for ensuring code can be understood by others and by your future self. Comments are short explanations written directly in the code to clarify complex logic or note why a certain approach was taken. Documentation can be more formal, describing functions, methods, and usage guidelines in detail, often using specialized tools like docstrings or auto-generated API documentation. Good commenting and documentation practices increase team productivity and make code more maintainable. In real-world applications, these programming structures are everywhere. A login system might use a user object to store account details, authentication functions to verify credentials, and Boolean variables to track login status. A calculator app might rely on variables to store user input, functions for mathematical operations, and loops to manage the sequence of actions. Automation scripts often manage files, restart services, or apply configuration changes using variables, functions, and objects to organize their logic. On the exam, you may be shown code snippets and asked to identify the role of variables, determine the scope of a value, or explain the behavior of a function or object. Some questions might focus on differentiating between methods and functions, or recognizing array usage within a loop. The emphasis is on understanding structure and terminology rather than memorizing complete syntax, which reflects how IT professionals apply this knowledge in practical troubleshooting and system support. Key glossary terms for this topic include variable, constant, scope, array, function, method, object, class, attribute, and inheritance. To reinforce your understanding, consider using matching exercises that pair each term with its definition, or annotate short code examples by labeling each part. Practicing these skills builds the ability to quickly recognize programming structures in unfamiliar code, a valuable skill both for the exam and for real-world problem solving. In IT environments, understanding these programming concepts improves collaboration between operations teams and software developers. System administrators who can read and adapt scripts, modify automation routines, or interpret application logs can respond faster to technical challenges. These skills also make it easier to document workflows and hand off tasks across teams. Logical organization and clear code structures are essential for reliable automation, maintainable systems, and effective technical communication. In the next episode, we will focus on programming organization and logic, including the use of pseudocode, flowcharts, branching, and loops. You will learn how developers plan and implement decision-based instructions that adapt to different inputs. Join us for episode 44, Code Organization, Pseudocode, Flowcharts, and Logic, as we continue building the development knowledge needed for the Tech Plus certification. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.